design of this baby in the left. Now, if and
Hello students, welcome to my YouTube channel VRacademy. We are here to discuss about the next topic in digital electronics, and that is master slave flip-flop. So we'll try to understand what exactly happens in master slave flip-flop. And in the previous video, as I have stated you or told you about, it will be able to resolve the problem of race around in JK flip-flop. Now how it will be resolving, that we have to know and that we have to understand. So first of all, we'll try to understand its construction. So basically, when we are talking about a master slave flip-flop, it is a combination of two JK flip-flops. Not actually, I mean, we are not using a JK flip-flop over here and JK flip-flop over here, because the output connection is done in only one case. So we cannot say that it is a combination of two JK flip-flops, but basic idea is that here we are using some combinations of flip-flop which will be almost operating as JK flip-flop, and this is the other kind of flip-flop which will be helping you to get the feedback connection from output to the input. Now exactly what happens in this case, if you have to draw this diagram, this is looking somewhat complex, but it is very easy to draw. I mean, what you need to do, you need to go for a normal SR flip-flop over here and similar SR flip-flop over here. But what you need to do, you need to have a connection from the output of uncomplemented output. It should be connected to the input at input to that NAND gate where K is connected. Similarly, the complemented output should be connected or feedbacked at the input where J to the NAND gate where J is being connected. Simple concept. You use two SR flip-flops, and for the second SR flip-flop, what you will do, you will have the connection of feedback. That means Q should be connected at the NAND gate where K is connected. Q bar is connected to the NAND gate where J is connected. Now once that is being done, I have said you previously also that whatever design that we are doing, it is totally dependent on the design of SR flip-flop. So once you know the SR flip-flop design, you will be able to understand the design or design of any flip-flop. So this is about the design part. First SR flip-flop, second SR flip-flop, feedback. That's it. This is the design of master slave flip-flop. Now the only change that we have made is we have given a direct clock signal to the first SR flip-flop, while a clock signal is being given with negation to the next flip-flop. So why it has been done? It has been done in order to resolve the race around condition. Now the question is how it is resolving the race around condition. So for that, we'll try to understand. Now let us suppose this is your clock signal. This is the clock signal, and I have said you in the all the previous classes, I have explained you that SR flip-flop will not start the operation if we are making clock equals to 0. If we are making clock equals to 1, then only the flip-flop operation starts. So for that reason, this line becomes very, very particular or peculiar while understanding the operation of master slave flip-flop. Now what happens when we are keeping the clock value equals to 1? That means this flip-flop is getting the clock value equals to 1. But think about this flip-flop, this set of flip-flop, or you can say this flip-flop. What is the input? Input is negation of 1, that is 0. That means this flip-flop for a particular time period will not be operating, while this flip-flop will be operating. That means we'll be getting the output X, will be getting the output Y for the value for that value where the clock signal is equals to 1. Now how that can be explained? You can clearly see it over here that if clock signal is high for this time period, we are not going to get the value of Q or Q bar. Why? Because this flip-flop is not operating when the clock signal is high. Because if you are making clock signal is high, this becomes low, and if it will become low, it will not be operating, and if it will not operate, definitely will not get any Q or Q bar. So that means for the first half of the clock signal, this flip-flop will be operating and will be getting the output X and Y, not Q and Q bar. So once we are getting this X and Y, after that what will happen? Once this whole signal will be down, I mean if this clock signal will reach to this point. Now after reaching to that point, what happens? This clock value will change to 0. And once this will change to 0, that means this flip-flop will not be operating and this flip-flop will start operating. Now if this flip-flop will start operating, what is the input to this one? This X and Y will be the input, and the clock signal is activated now, and in that case you will be getting the output. That means when the clock signal is low, at that time we are going to get the output. So you can clearly visualize that it is resolving the problem of race. How it is resolving? Until and unless we are going for a complete clock cycle, we are not going to get any kind of feedback from output to the input. And that is how it is resolving the race around, which was happening to be, which was happening when we are taking the value to be j equals to 1, k equals to 1, level trigger and all. But here, even after taking the level triggering of the flip-flop, there is no case of race around. And the reason being, I have already explained you. So this is what I have written. When we are going for trying to understand the operation of that one, we have written j equals to 1, k equals to 1, level triggered, and clock equals to 1. At that time, x and y are observed. I mean, x and y are observed, but q and q bar are not obtained. Not obtained. Q and q bar are not obtained. Why? Because this flip-flop is not operating, hence we are not able to get the q and q bar. Now once if j equals to 1, k equals to 1, level triggered and clock equals to 0, at that time what happens? Q will be operative and we are getting the value of q at that time as well as q bar. Hence the problem of you can say race around is resolved by this method, and that is what I have shown in the case of that clock and Q. Initially we were not getting any kind of output because this flip-flop was not operative. Once the level goes down, it will be operative, but at that time input will not be active, and that is why we are getting the perfect output without any race. So this is all about the master-slave flip-flop. If you have any doubt, you can come up with that. But this is very simple to understand its design, its operation, and how it is resolving the race condition. So now we have understood all the three parameters which is resolving the race condition. Now once again I am just repeating a bit from the previous video that race condition occurs because of level triggered, j equals to k equals to 1, and when the clock signal is very larger than the propagation time period, or you can say t on is very larger than propagation time period, that is tp. How to resolve that? Making tp greater than or equals to comparable, or you can say making tp comparable with the t on or tc by 2. If you are doing that, you will be able to resolve that. Second thing is you have to go for edge triggering, and third one is this master slave flip flop, which I have explained you. Master slave flip flop, how it is operating and how it is resolving the race around condition. So this is all about race around. What are the reasons why a race around occurs and how it will be resolved. So if you have any doubt, you can come up with that. Thank you for joining, and if you have any kind of suggestion, you can come up with that. Thank you very much.